presentation, I'm covering the certification process for a passive house building, not just from a certifier perspective, but also from a consultant, modeling, and builder perspective, so you can get an understanding of who's in charge of doing what are the biggest causes of failure in a project to meet certification, and what to expect throughout the process. Now, Emu started as an architecture company about 15 years ago. We have working experience in Italy, Germany, Australia, and the US, which allows us to have access to research and information from other countries and from other climate zones, which we can then bake into the projects that we do and the training that we provide to builders. Emu is the actual Australian bird. It's not an acronym, it's just a bird. We started in Passive House in about 2010, and right now, since at least 5 years, we have 100% Passive House projects. We do not do code compliance, we do not do net zero, we do Passive House. We do Passive House very well, and we do training mostly, and we support builders in the first few projects, and that is the consulting that we do. We are now the biggest training providers for Passive House builders in the country. This map shows the 1 week in-person hands-on workshops that we had just in 2022. So we have a trailer that we take the workshop on the road, and we meet builders from across the country, and we teach them about Passive House. We operate in a very niche market where hitting 0.3 ACH50 at the blower door test is normal instead of 3 ACH50 as code minimum. And this is a really big drive for us. Some of the presentation you're going to see today are informed by how normal it can be to hit that high level of performance. In our niche, hitting 1 ACH50 is kind of a failure, while it's still way below code minimum performance. We have Passive House consultants on staff. I am the only certified PHPP expert in Colorado and many states around. And I'm also the only certifier, licensed certifier in Colorado for the Passive House Institute. Today, as I mentioned, we're going to go over the certification process, starting off with an overview of the Passive House standards that are operating in the market, looking at design stage, construction, verification, and certification. Disclaimer, this presentation was put together specifically for the Colorado Green Building Guild event in October 2022 in favor of the Marshall Fire victims in Boulder County, Colorado. Passive House requirements listed in these presentations are mostly driven by Climate Zone 5. And while most of these requirements do not change in other climate zones, please keep in mind that if we talk about triple pane windows and you are in Florida, Climate Zone 2, you're not going to need triple pane windows. So this information is based on that. And we also try to compare the certification requirements of PHI and PHIUS to the best of our abilities. We are actually working on a white paper comparing the two, and we try to put together this presentation today to the best of our abilities and trying to portray both standards as accurately as we could. So talking about Passive House standards first, and really Passive House concept first. We have a design of a building, floor plan, building section. This is actually a design for my personal house up in the mountains. And we are implementing 5 pillars of Passive House. First of all, super insulation. The assemblies are much more insulated than code minimum. And this sometimes comes as a surprise to an architect that they may think that they can do Passive House in Climate Zone 5 with the same R20 6-inch walls as they do code minimum. That's not going to happen. Let's just change the page on that. Then we want to avoid thermal bridging. We're going to see what that means in terms of requirements, but we want to avoid mold and condensation, something that code does not cover. Passive House does. We want to have high quality windows and doors in order to meet thermal comfort. Again, this is something that code is decades away from implementing, and Passive House does very well, and PHI has the comfort requirement to address that. We want to be very airtight, and we want to have a fresh air ventilation system through the ERV or HRV. Now, for single-family homes, thermal mass, the impact of thermal mass is highly negligible. If you Google what's a passive house, you'll find thermal mass there. The reality is that for residential projects, the impact of thermal mass is negligible. We've done dozens of passive houses without thermal mass, and the comparison is that you cannot get to a passive house without insulation, but you can get to a passive house without thermal mass. So that is a big misconception in the market right there. And the form factor we're going to see today is one of the very most important things to make a passive house project cost effective, and that is where architects are extremely crucial to this part of the process. So the green and orange here highlight the amount of insulation that we need in the walls of the building thermal envelope and the air barrier that runs on the interior of that. We have two institutes that work independently and separately from one another. The International Passive House Institute on the left, PHI, and the Passive House Institute US, PHIUS. And they used to work together until like 10 years ago. They no longer do that. It was a bad divorce, and we need to move on from that. Now, for new builds, they offer different certification standards. PHI on the left offers what they call PHI Passive House. The Classic, Plus, and Premium is something that has to do with classes we're going to see later today. And PHI also offers a lower entry-level certification standard that actually performs very similar to the PHIUS 2021 standard that is called the Low-Energy building. PHIUS offers a performance-based standard, the PHIUS 2021 Passive Building Standard, which later I have shortened to PBS just because Passive Building Standard is very long. And the alternative is a prescriptive approach that PHIUS offers for single-family homes. PHI, the international standard, does not offer prescriptive approaches because in their experience that is very risky in terms of actually delivering the performance that one expects from a passive house. We do not address remodels in this presentation. Both institutes have standards specific to remodels of existing buildings, but because this presentation is put together mostly for the Marshall Fire victims, we're not going to address remodels right now. Modeling, passive house requires energy modeling, period. It came as a surprise to a few certified consultants that they have to do passive house modeling in order to get the building certified. PHI uses PHPP, the passive house planning package, and they also have a 3D interface for SketchUp called Design PH, which is optional, but it makes it a lot easier, for architects or consultants to do the modeling in the first place. And also it makes it a lot easier for third-party certifiers like ourselves to certify and verify what you did. So literally we issue a different fee if you do or if you don't have the 3D modeling, because if you don't have a 3D model, it's a lot harder for us to verify what you did. PHIUS uses WUFI Passive. WUFI stands from German Wärme und Feuchte instationär, which is a software that initially started just for moisture management analysis for just individual assemblies, and then after the divorce, in Germany they developed a software, the Fraunhofer Institute, to do passive house modeling, which is WUFI Passive. And both PHI's PHPP and WUFI Passive are based on the same ISO standard 13790, so it's the same core of modeling, and so calculating the same building with one or another with the same parameters, I would expect the results to be very close to one another. What difference is the certification goals that PHI and PHIUS set for their project. But if you model the same building with the two different softwares, the same identical building, then the results from the two softwares is supposed to be coming in very closely. So I mentioned that PHI and PHIUS have different certification criteria, and that is very hard to navigate because some may vary by climate, some may vary by building size and whatnot. So we've been working on a study, over 50 projects that we've been working on at Emu, across the country that is depicted in this picture to compare the two standards and try to have a statistical approach in determining the differences between the two. This is supposed to come out in November 2022. It was supposed to come out in November 2021, but life happens and things go along. Just in Colorado, we have dozens of projects, and so we use this in this presentation a little bit to compare the two standards. In terms of overall efficiency, that is the reduction of heating and cooling compared to the 2018 code, PHIUS 2018 and PHIUS 2021 achieve about 60 to 63% reduction for the performance-based, reduction of site energy for heating and cooling compared to the 2021 code minimum compliance. The PHIUS Prescriptive achieves about 50 to 55% reduction compared to the 2018 code baseline, whereas the low-energy building, as I mentioned earlier, performs, it is not called Passive House, but it performs better than PHIUS Passive House, just if you look at the actual numbers. And this is based on about 50 projects that we have, and this study is going to be published soon. PHI's Passive House, on the other hand, is the most performing in terms of reducing heating and cooling, with a reduction compared to the 2018 code of over 80% in average. So the certification requirements we looked at through the lens of the Marshall Fire, which is located in Climate Zone 5. And we have 19 projects that we used for this analysis. So in terms of heating demand, PHI Passive House is set at 4.75 kilobtu per square foot a year maximum heating demand that you're allowed to have. Low energy building, PHI low energy building has twice that, so it's 9.5 is the limit for the heating demand overall. PHIUS, as I said, there's quite a bit of variability depending on size and complexity of the project. Over the 19 projects that we saw, it ranged between 7.8 and 11.8, averaging 9.8 kilobtu per square foot a year, so slightly less performing than the low energy building. In terms of cooling, again, Passive House, PHI Passive House has 4.75 sensible cooling plus some allowance for dehumidification, which in Colorado is a dry climate, so that is 0. Low energy building has 9.5, and PHIUS, over the 19 projects that we looked at, had about a similar range there. This may need to be updated because the variability is actually between 4.5 and 9.5. So the numbers listed under the PHIUS logo, I apologize, they're not up to date, but the graph is up to date. And the average for cooling is about slightly less than 7 kilobtu per square foot a year. Something interesting is that the variability of PHIUS also changes depending on the project size. PHIUS uses a surface area related parameter, the Q50, instead of the ACH50. And for these projects, we converted those numbers to the ACH50 so we can speak the same language. PHI Passive House has a maximum allowed air leakage at the blower door test of 0.6. And as I said earlier, once you get into this, doing 0.3 becomes kind of normal. So 0.6 is not intimidating at all. Low energy building is less than 1 ACH50. And for the study, PHIUS performance-based, the one in the blue column on the right-hand side, has a variability between 0.85 and 1.56, with an average of by PHIUS of 1.2, so twice as high air leakage, percent higher air leakage for PHIUS performance-based compared to the low energy building. Now, interestingly enough, the prescriptive standard for PHIUS requires the building to be tighter, and the average is listed here between 0.57 and 1 ACH50 at an average of 0.81. So in terms of air leakage, the be tighter than the regular PHIUS. Core requisites. If you look at the details for PHIUS certification, there are some core requisites. So you need to certify the building not just with PHIUS, but you're required to also follow the EPA Energy Star Certified Homes program, the EPA Indoor Plus program, as well as the DOE Zero Energy Ready Home program. Whereas PHI doesn't do that. It's just PHI. So it's either PHI Passive House or PHI Low-Energy Building. Other requirements that you may be wondering about, net zero energy is not required for certification. You can get there, but it's not required. Carbon, it is not part of Passive House certification. You may use low embodied carbon materials. You may not. That is up to you. It's great if you do, but it's not part of Passive House certification. All electric, going heat pump, all electric, whatever, it's also not part of the certification, as it is not part of certification to have prohibition about specific materials. There is a myth that you cannot use foam in Passive House. You can, and it is up to you to do that. With regards to, for example, spray foam, you want to have realistic performance data, which are much lower compared to the label value of spray foam products, but there is no prohibition in terms of foam in Passive House projects. A quick overview of the parties involved at different stages of a Passive House project. For Passive House, you have a Passive House consultant that may or may not be certified, but the Passive House consultant we're going to see later is the person who's in charge of all the things passive on the team, including the energy modeling. In fact, the Passive House consultant does collect some of the construction documentation. We're going to see what it is. The testing, especially for the blower door test, can be done by any blower door test technician out there, as long as they have an equipment and they follow the ISO standard we're going to cover later. But they do not, the PHI does not require the blower door test technician to undergo any specific type of training, other than being trained in doing blower door tests. But there's no PHI certified blower door test guy sticker. The ERV, HRV fresh air system we're going to see later in this presentation, they need to be commissioned, and they are typically commissioned by the supplier or the installer of the system per the specs we're going to see later. And then certification itself for PHI can be done either by PHI itself or by a licensed certifier on behalf of PHI, like myself. For PHIUS, you have a Passive House consultant. You have a separate PHIUS rater that you have to hire to collect information during construction. The blower door test technician, I'm unclear if there can be anyone or it has to be certified by PHIUS. Similar consideration for the commissioning as for PHI, and certification is done by PHIUS directly. Now let's look at the design stage. So this is, we talked about a little bit of the infrastructure for certification. Let's look at things that need to be addressed and taken care of during design. Now, design may cause a building to fail Passive House certification. If you were to try and certify the building in this photo, it would be a mess in terms of Passive House because it's a very complex building envelope. Passive House is all about the skin. It's all about the exterior walls. It's all about the insulation of the ceiling, the floor. And the more complex the building is, the more corners and cuts you have, the more the project is going to be expensive, regardless of Passive House. And so this is a big responsibility for architects to tune down the non-artistic creativity here and actually be responsible for the designs that they're doing. So the more complex the shape of a building thermal envelope, the harder it is to make Passive House. And a complex architectural design may make it impossible for a building to meet Passive House. Passive House is not something that you throw money at and you get it. It needs to be efficient. You can throw a lot of money to the problem and try, but if your design sucks because it's very complex, you're out of luck. You're not going to get there. This is not a checklist. Okay. The form factor is what defines the complexity of a project, and that is the area of all the exterior envelope assemblies. So the area of the exterior walls, the area of the ceiling if your thermal boundary is at the ceiling, or the area of your roof if your thermal boundary is at the roof, the area of your floor, the area of your slab, depending on where your thermal boundary is at the bottom, all of those area of the envelope divided by the treated net floor area, net of the interior walls and the exterior walls as well. And that number, the form factor for a single family home, we want to see in the range of 2.5 to 3.3. If you're in that range, then it's going to be fairly easy and cost effective to get to Passive House. If you are much higher than that, it's going to be much more expensive and possibly impossible to get to Passive House. So let's look at the Passive House designers and consultant. The consultant is the person in charge of Passive House on the design team. Specifically, they're in charge of developing and updating the energy model, whether it is PHP or PHI Passive. They may also be in charge of covering other scope, such as the thermal bridge modeling. Sometimes we do the thermal bridge modeling for other consultants on other projects where we are not the consultant, we just do the specific thermal bridge modeling task. So the consultant is mostly and primarily in charge of the Passive House energy model, as well as interfacing with the certifier. In fact, the Passive House consultant is the one point person between the certifier and the team. We had teams where we started receiving information from the builder, from the homeowner, and that does not work. We need to have one single point person throughout the process that is in charge of Passive House on the team, and that is the Passive House consultant or designer. Now, we talk about consultant or designer because in the international accreditation for the consultant, you have in Europe or international, actually, this is Australia, China, everywhere else than the US, PHI offers professional accreditation for people that do the modeling, and they can be certified as designers or consultants. The difference here, the only difference here between the designer and the consultant is that in Europe, you cannot call yourself a designer unless you are a registered architect. So I, Enrico, I'm also, other than Passive House certified, I'm also a certified Passive House designer because I'm a registered architect back home in Italy. Whereas if I was not, or if anyone that is not an architect back home or internationally passes the exam, it's the same course and it's the same exam, it's identical, it's the same path, but you become a designer or a consultant depending on your previous professional accreditation, that is, whether or not you are a registered architect. Now, for PHIUS, there's only the certified consultant that applies to both. There's some confusion in the market about consultant for PHIUS, that is a registered trademark, but the Passive House consultant has been used internationally for decades, so that trademark kind of does not matter. Design, we talked about the form factor, and for cost effectiveness, the first place is keep it simple. Keep the building envelope simple. If you do that, it's going to be a lot easier to air seal, to insulate, to get the right sequencing down. It's going to be a lot cheaper. For example, garage excludes from the Passive House building envelope. That is a friend advice that I give you. We have tried in the past to include the garage in the Passive House envelope. Do not do that. Attic, crawl spaces, basement, typically include them in the Passive House building envelope, typically, especially because they make your form factor look better. And the glass area, we have received some projects to look at for the Marshall Fire in Clemens on Fire, where the entire south wall is glass. And like, I understand you want to collect some passive solar gains, but that is ridiculous. Like, that is very detrimental. In the first place, windows cost about 3 or 4 times per square foot more than a wall. So the more glass you have, the more expensive it's going to be. It's as simple as that. Plus, there are ways to increase the amount of energy coming through the glass by just adjusting the coating on the glass. So you don't need the entire south wall to be glass. You don't need to live in a fishbowl. And that is the feedback that the energy model provides you with. And do expect much thicker walls than code minimum if you expect to do Passive House in Clemens 5 with a 6-inch R20 wall. You are off with a wrong start. So expect at least twice as that thickness and R value. Typical causes of thermal bridging. This is something that we just put a list together. We need to talk more about that, but that's why we do training. Avoid metal beams and posts in insulation at exterior walls, exterior floor, exterior ceiling, or penetrating through the envelope from the inside to the outside. Concrete, especially slab or walls, penetrated to the envelope. That is a thermal bridge. Metal flashing through the insulation, metal flashing, in my experience, is the most unaddressed and most detrimental source of thermal bridging in the country today. It is, nobody talks about that, but if you have a piece of flashing going through your insulation, that's a thermal bridge. That cuts your insulation value down. It cuts down the performance of your building, and it may cause more than condensation. So if you do want to have flashing going through your exterior insulation, there's other products such as self-adhered flashing or vinyl flashing. Do not use metal, period. Metal seal pen penetrating under windows, that is very popular for some builders. That's a huge no, period. Uninsulated windows and door install gaps. Installation gaps between the window and the roof opening needs to be insulated on all four sides, period. Let's move on. Gaps in insulation settling, that all leads to underperformance of the building. And then timber member in insulation, such as your studs, they do cause thermal bridging, but compared to, say, the metal flashing or steel post or whatnot, they are mice compared to elephants. So there's a lot of effort out there to try to mitigate mice, and elephants are left to roam free and damage your building. So be aware of what you're doing. And you really want to know what is important to address and what is not, because that drives the cost up and down. If you want to be cost effective, you really want to know what's a mouse and what's an elephant. Some of this cannot be avoided, and the first place we want to avoid more than condensation. And so the consultant on the project needs to do the modeling, the thermal bridge modeling, to assess whether a thermal bridge is a problem in terms of mold condensation and performance gap or not. So thermal bridge modeling is typical condition that needs to be modeled for passive house include transition junction details, say from a wall to a ceiling or from a slab to a wall. Those are typical transition junction details. Structural elements such as, hey, I have a steel post in my wall, do I need to model it? Yes. Let's move on. Window and door install details, because there's a lot of good and bad that we can do in designing installation details for windows and doors. This is not looking at the quality of the install. It looks at the quality of how that install detail is designed. Okay, so this is really looking at the installation drawing and modeling that and see if there's any issue in terms of thermal bridging and mold condensation. Suitable software out there, we have Therm, which is free and it sucks, but if you're the passive house consultant just for a one-off project, you can go with that. Flix is another one. We use Mold Simulator, but it costs like $5,000. So there's a cost to that. And any other finite element software out there can be used as long as it complies with ISO standard 10211. There are other types of thermal bridge software modeling options out there that instead of using the finite element software, there are finite differences and finite volumes. They are not suitable for passive house. They are not accurate enough. For example, ArchiCAD has a module for thermal bridge software built in that is trash. Do not use that. You need an actual FAM software. All of these require the user to be competent in using them. This is a list of the ISO standards that you need to, if you decide to do the modeling of thermal bridge software yourself, these are the standards that you need to comply with. And our certification fees vary depending on the quality that we see in this kind of modeling. If you're a first time trying, your fees are going to be higher, period. That's just the complexity of the process on the modeling side. On the construction side, it's a lot simpler in my opinion. Dynamic moisture modeling, it's something that at the discretion of the certifier, so if we receive an assembly that we believe is going to have moisture problem, we may require extra documentation from the team to to prove that that assembly is not going to have moisture problems. There's a couple of softwares out there, same as for the thermal bridge modeling software. This requires knowledge in building science. If you want to undergo this route, you want to be prepared for this. And we want the modeling to be done according to ASHRAE standard 160. Now, there are certified wall systems out there that do make life easier because somebody has already done this. The thing that is often misunderstood is that while the wall system itself is certified, that does not translate to the building where you apply that wall system automatically being certified. Think about certifying a design building with Legos. If your individual pieces of the Lego are certified, it does not mean at all that your building is going to be certified regularly. You still need to do the full passive house model. Windows and doors, there's a database for that. Windows and doors do not need to be certified. Certification helps. Certification of a component, wall system, windows, really helps in the process of certification, but it may be more expensive. So the windows and any component, they do not need to be certified, but they do need to meet the criteria and the requirements for passive house. So you as a consultant, you as a builder, the consultant is going to do this. So you need to depend on the consultant. As a consultant, if you choose to go for the non-passive, for the non-certified route, then you as a consultant need to verify the comfort criterion and the hygiene criterion via modeling, and that it takes competence to do that. For Climate Zone 5, do expect needing at least passive house C-grade frame, probably better than that. So probably more like a B, but that depends also on the design of your building. So if you have a very compact building, you can get away with a C, and if you have a more complex building, you may need a B grade or an A grade. C grade and A grade, we have training material for that to show what that is. Triple pane windows, Climate Zone 5, you will not certify passive house with a double pane window because of comfort. It's not the energy, it's comfort. So it's triple pane, and you really want to look at thick glass units, 1.5 to 0.8 overall glass thickness, filled with argon or krypton, so gas fill, low coating, warm edge spaces, so on and so forth. There's a lot of details that go into windows. The type of solar heat gain coefficient, low gains, medium gains, high gains, typically in Climate Zone 5 is going to be high gains, but that is something that is really driven by the building energy model. Now, there's a temptation of customizing the coating by the elevation of the building. You can do that. It's more complex. It typically, in my experience, unless you have if you have a ton of glass facing west, that is the one case where I would recommend speccing different types of glass by different orientation of the building. But that is an architectural issue, in my opinion. If you don't do that, then you can get away with using the same kind of glass throughout the building, and that simplifies things a lot in the order and procurement and install of the windows. This applies to all windows, exterior doors, skylights, curtain wall systems, as well as the door to the garage. The garage is unconditioned, so the door to the garage, which is typically just an interior door, for passive house is the boundary of the building envelope. So we do want that to be insulated, and we do want that to be airtight, as well as any door or hatches to, say, an unconditioned attic, an unconditioned basement, an unconditioned crawl space, or pet doors. They are all part of the passive house boundary. So they all need to be airtight, and they all need to be sealed. Okay? So this is something that get away from what you've been doing for 30 years and try to think about what your building envelope boundary is. So a pet door, I'm using this because literally we had projects trying to go to passive house, and then they wanted to use this kind of pet door. That does not fly. Period. Passive house is a better product. We don't do that with using the same products. Now, the air barrier is something important, and it scares a lot of builders, but it is something that once you get your head around, it's actually pretty straightforward. We want to have one single continuous and uninterrupted air barrier on the warm side of the insulation, so on the inside. On the little section blowing on the right hand side here, the air barrier line is the dashed line on the interior of the insulation, which is green in that section. Now, it does not mean that it's going to be the drywall. The drywall is not an air barrier. It does not need to be necessarily right at the drywall. It can be a little bit better into the assembly, but it needs to be on the interior of the bulk of the insulation. But we need one. There are people out there, there are companies out there that promote a primary air barrier, a secondary air barrier, a third air barrier, and that is all bullshit. You want to have one single bucket. If you want to hold water, you want to have in a bucket, you want to have one single bucket that does not have holes, does not have cracks, and that is your one single seal. Same goes with the air barrier. You want to have one single continuous and uninterrupted air barrier. If you think about water, one bucket that does not have holes will hold water. One bucket that does have holes does not hold water. If you add a second bucket that has holes to a bucket that already has holes, two buckets that have holes will not hold water. So forget about primary air barrier, secondary air barrier. That is bullshit. You want to have one single air barrier to be continuous and uninterrupted all around your building envelope. And you're creating a balloon. And once you get your head around this, that's going to be very easy to do. Must be durable. We don't want to pass the blow window test today and then 5 years down the line, the building is leaking. In order to do that, the followings are not durable air barriers, so they are not suitable for passive house application. Drywall is not a durable air barrier. We have data to show right now. Taped insulation boards, they are not durable air barriers. There's no data to prove that is a durable solution. Latex paint, that is not a durable air barrier. Spray foam shrinks and cracks, so that is not a durable air barrier. ICF is not a continuous air barrier. We have data showing that ICF can get your building to 2 ACH50, to 1 ACH50, but we have consistent data showing that without an additional actual air barrier applied to the ICF itself cannot deliver the passive house airtightness requirements. Aero barrier, we have good experience with, but we recommend that to be just a backup, not the primary strategy for the air barrier of the building. This is some data to prove that drywall is not an air barrier. So at the top, if you can Google Proskiv air barrier study, and that leads to an increase in buildings. They looked at 10 years over multiple buildings. You can expect about 0.2 increase in your ACH50s, meaning that if you start off with 0.6 ACH50 and you go from 0.6 to 0.8, you have about 30% increase in your air leakage. That becomes noticeable. Whereas like air barrier membranes, subfloors and whatnot are much more durable, which is depicted on the right hand side of this graph, leading to about less than 10% increase in air leakage over 10 years. Same, spray foam is not an air barrier, and taped rigid insulation is also not an air barrier. Fresh air systems, fresh air ventilation is required to be balanced and continuous in passive house. The ventilation rates are dictated by the passive house indoor air quality requirements. So they are not driven by the heating and cooling requirements. This is a system that is completely separate and different from a forced air system. This slide calls out for a fresh air system. It does not read forced air system. So these are completely different things, and there are more details to this, but you want to think of something completely different from a ducted forced air system. There's a database for certified ERV and HRV units in the database. Climate Zone 5, you want to have an ERV that recovers moisture. I'll say that again. You want to have an ERV in Colorado Climate Zone 5. Some units that are not certified with Passive House have an heat pump active heat recovery, such as Serve and Minotail, and these are significantly less efficient, if you look at the actual numbers, than passive heat recovery units that are the more regular ERVs and HRVs out there. Active heat recovery units may be used in certified passive house buildings, but you will see the penalty that you pay in the energy model. So that is why you can use a minute or serve in a passive certified passive house building, but you're going to suffer. You will need to insulate more because that ERV or HRV is less efficient. So your walls are going to be thicker. You're going to have more insulation in the attic and whatnot. Units that are not certified, for example, there are a lot of units that are rated with the Home Ventilation Institute, the HVI, but they're not certified with Passive House. You can use this as long as the sensible heat recovery, not the total heat recovery, the sensible heat recovery is greater than 87%. As well as the consumption is less than 0.757 watts per CFM, and they can install a MERV 13 on the filter on the intake and a MERV 8 on the exhaust. If that non-certified unit meets these requirements, you can use that in a certified passive house project. Now, there are the Lunos on the market, and you see information here about how to use them in PHPP. This information is unfortunately incorrect, and you cannot use that in PHPP, period. There is the rating that they have, 89%, that is done with very inaccurate German rating standards, and that's unfortunate. The actual performance is a lot lower. They declare 90%, the actual is between 40 and 60%. This graph shows 68, but it's not efficient enough for the passive house project in Climate Zone 5. So do not use Lunos in Climate Zone 5 if you are trying to certify the building with passive house. Renewables, PVs and whatnot, passive house is all about conservation before compensation, and passive house does not allow energy trade-offs. The building must be efficient. So you cannot have, in Climate Zone 5, you cannot have an R20 wall and have a very inefficient building, have a ton of PVs and certify that as a passive house. You cannot do that because your envelope sucks for Climate Zone 5. So there is no compensation in passive house. Renewables such as PVs only impact the class of passive house, and we're going to see in just a sec. You can certify passive house classic with 0 renewables. So if it doesn't fit in your budget to have PVs right now, you can add them in the future. But right now you can certify your building as passive house. And the classes that we see here, they have nothing to do with net zero. You see numbers at the bottom, you see numbers on the left. They are referred to different areas of the building. So don't try to subtract 50. I'm producing 30 kilowatt hour and I'm consuming 30 kilowatt hours per square foot or whatever. I'm going to be net zero. This graph has nothing to do with net zero. This is one of the hardest things to explain about passive house certification. There is no net zero in passive house. If you want to do a net zero calculation, you do that elsewhere. You can very easily get to net zero by means of having a passive house building, but this graph here and these classes have nothing to do with net zero. The X here shows the position of a project based on certain condition of climate, design, R values, equipment and whatnot in terms of energy demand and energy production. So in this graph, if I add renewables or remove renewables, my X is going to be up and down. And if I make my building more or less efficient by means of insulating more, having a more efficient heating system and whatnot, then my X is going to be moving left to right. For the Marshall fire, you just need to get to the classic, but if you want to get to plus or premium, this is how to do that. So it's a combination of making your building more efficient, as well as, so even for the classes, you cannot just dump a bunch of PVs on your project because your X is only going to be up vertically, but you also need to move to the left, and to move to the left, you need to reduce demand, that is making your building more efficient. Design documentation, this is a list of documents that you need to submit to the certifier throughout the process and at the end to verify that your building meets certification. And we recommend starting that process early in the process, in the project stages, because once your building goes through permit or pricing, it's very hard to go back and make significant changes if you're far from meeting passive house. So we do a first review of the project. and this is when we, Emu, are the certifier and not the consultant. It's a 2-hour flat fee review, $500. We get, ideally we do this before permit application because, hey, you need 20% more windows. If you do that, then permit you will need to resubmit. So this is something that may be impactful on your design, and you may want to do that before you apply for permit. The goal is to assess the likelihood of meeting Passive House certification in the first place, review the accuracy of the modeling, and based on that, we, Emu, can actually give you a fee for the entire certification process. If you email us, hey, this is my drawing plan, send me an estimate for the certification process, you're gonna receive an email saying, hey, we do this flat fee 2-hour review, $500, and after we do that, we give you the actual quote. Because as you saw in the previous steps, if the consultant on your project, if they've done a ton of Passive House, then they know what they're doing, the certification fee is going to be lower. If they are a first timer and they need to go back and forth a lot of time with us, the certification fee is going to be higher. And so this first pass allows us to determine just that. This is not a pre-certification. There is no such a thing as a pre-certification with PHI, period. At the construction stage, you can fail Passive House at the procurement, even just to buy the wrong material. Common errors include getting quote specs for blown-in insulation, specing the wrong type of density, or using non-durable tapes or sealant for the air barrier. This is the most common one. When you get a quote for windows and doors, 12 out of 10 times, literally every single time, the quote gets back with the wrong solar gain coefficient. We checked that many times. We had projects that wanted to be certified. They spec'd high gains glass. They got a low gains glass installed. The building consumes twice as much the energy that it was supposed to be. Passive House, bye-bye. That is something that you don't go back from. So this is extremely important for you to realize. Glass spacer may cause condensation, wrong installation hardware, non-certified ERVs and HRVs that don't meet the requirements. So these are all common mistakes that we see in just buying stuff. At the construction failure, you may have job sequencing that is critical for air sealing, or you may have thermal breaks that are critical to avoid thermal bridging. This is, for example, you're looking at a framing. The blue stuff that you see is an air sealant tape over a top plate, and you understand that you need to install that before you frame the wall on top of it. And if you don't do that, then the air leakage associated with doing a much poorer quality air sealing job may cause your building not to meet Passive House air sealing requirements. This other photo shows some thermal breaks that we need between an interior concrete wall and a concrete wall of a planter outside. Those two walls, it's concrete, they cannot meet each other. You see the white insulation at the foundation, which is going to be paired at the top with exterior continuous insulation on the outside of that plywood sheeting. And if that concrete wall was to go through, if we don't install those thermal breaks, we would have a significant thermal bridge. So this is something that you need to tell your crew or tell your builder to do at the right time and in the right fashion. Other things, you can install windows and doors incorrectly. Your trades may slash through your air barrier. Your electrician doesn't know what that white membrane is, so they cut straight through. They don't tell you, so you have big holes in your air barrier and your building fails. This is all very common. It can all be prevented. This is all about sequencing, communication, and clear goals. Air sealing is more about clear goals than expensive products, in my opinion and experience. But this needs to be designed for, and needs to be communicated, and needs to be supervised. So this is the two accreditations. PHIUS has certified builders. PHI calls it certified Passive House trade person, which is basically the same as builders, because it is for builders and other construction professionals. It's not really for trades, but it's more a difficult translation from German. Just like the Passive House consultant is not required to be a certified consultant or designer. It just makes it a lot easier because at least you understand what you're doing. For the builder along the same line, you're not required to be a certified builder to build a passive house. But if you do get the training, it's going to be a lot easier. And it's easier for the builder because it's very helpful in understanding pricing and job scheduling. It's critical for the site supervisor for quality assurance, and it can be very important for framers as well to understand sequencing and understand what's going on inside the framing. So we recommend builder training for these 3 figures plus anyone really, because there's not such a thing as too much knowledge on the job site. That is never a problem. Verification process, we talked about the design documentation. Now there's construction documentation. Typically the consultant or the builder take photos, lots of them, to look at very sensitive passive house related job sequences. We don't care about the countertop, we don't care about the floor tiles, we don't care about the paint. We care about thermal breaks, we take care about air barriers, we take care about ERV, we care about passive house stuff. We have our own, geekiness. Need to collect, the consultant, helped by the builder, need to collect all the data sheets of all the passive house related materials, including insulation, air barrier, windows and doors, HRV, blah, blah, blah. Because me as a certifier, I need to know what insulation went in that wall. I need to know what's the R value. I need to know what's the perm rating of that insulation. So I need to be provided with not just with photo of that insulation. That insulation needs to have a name and a last name. That is a manufacturer name and product name with all kinds of specs associated in the data sheet. I need to know, basically have an ID for that product. We also need as-built layout drawing plans for the domestic water lines, ERVs, heating and cooling system, because this is all part of matching the energy model with what was built. Regarding testing, blower door test is the test that measures the air leakage in the building. Passive house requires the final one, which we're going to see the next one, so that you are required to only do one. Sorry, for certification, you submit the data only from the final one. But we strongly recommend to do preliminary blower door test before drywall, or basically at the time where the air barrier is still accessible, so you can detect leaks and fix them. So, for example, this photo shows the smoke pan, and the smoke is going between the sash and the frame of a window. So we detected a very defective window in the case. This was, at the preliminary test, you can use masking tape on ducts or things that are unfinished yet, unlike the final test where you are not allowed to use any masking. In this other window, we found a gasket that was defective, so that needed to be replaced, and we added masking on it to see how much that impacted the overall performance value. So again, the preliminary blower door test is not mandated by Passive House, but it is strongly recommended, because while the air barrier is still accessible, then you can fix it. Whereas if you start putting your finishes on, then you can no longer fix it, and you may fail the blower door test, you may fail Passive House certification. The final blower door test, this is something that it is different from what the regular Joe does for the blower door test. The good news, because it's a different standard, it's ISO 9972, and it's not the ASTM standard. Good news is that with the same exact equipment, the regular Joe can do the ISO standard modeling, the test with the same exact software and same exact equipment. It is required to be both a positive and negative pressure, because some components of the envelope perform better under positive pressure, and some others perform better at negative pressure. And we need to have multiple points, multiple and different pressure points. So ACH 50 is air changes per hour at an average of 50 Pascal, but we want to have 10 incremental steps of pressure at an average of 50 Pascal. So this test goes from 25 Pascal, take the measurement, then 30 Pascal, takes the measurement, 35 Pascal, takes the measurement, so on and so forth for the positive pressure, and then you do negative 25 -30, so on and so forth, and then the final ACH 50 is the average of all those numbers. For the final blower door test, that is done once the building is complete. All of the appliances are in, all the things are in, and there is no mask. And the only thing that is shut at the final blower door test is the intake and exhaust of the ERV. Everything else has to be per the final use. The commissioning, somebody, the consultant, determines the design airflow rates for the individual interior registers for supply and extraction for the fresh air system. And then somebody needs to make sure that in the field, the system actually delivers that. And there is no such a thing as an ERV or HRV that balances itself at the individual registers. So the individual interior registers need to be manually adjusted to match that performance, that extraction or supply airflow. So that is something that needs to be done manually as part of the commissioning. Certification process, this is a typical flow chart that we have available on our website that shows basically when we are the certifiers, then you see on the left hand side a column with the different stakeholders, and at the top you see the different stages of a project. And we talked about the first certification review, ideally before permit, because before permit you can still make significant changes to the design, and then at the end we basically received the documentation by the consultant on the project. With the consultant on the project is our single point person between us and the team, and they're in charge of collecting data throughout the process. We are available for support during this process, but that is something that is going to impact our fees, as you can understand, because that impacts our time. That being said, thank you for your attention and listening to this, and you can send us an email if you have any questions about Passive House process, certification, modeling, and so forth. Thank you.